Welcome to Math Master. This is Saritha. Today we are going to discuss a topic of powers and exponents in the topic of algebra. Okay, so we usually use the word 2 power 3, 3 power 3 and 4 power 5 and so on. So what do you mean by a power? A power is nothing but it is an expression representing repeated multiplication of a same number. Yes, it is nothing but it is an expression representing repeated multiplication of a same number. See, I am taking an example 2. I am multiplying this 2 with itself number of times, repeated times. 2 into repeated number and I am multiplying so many times. Yes, this is called a power. Okay, how can we represent if this 2 is multiplied by 4 times? If this 2 is multiplied by 4 times, then we call this as a fourth power of 2. Fourth power of 2. Okay, so this we call it as a fourth power of 2, or you can represent it with 2 to the power of 4. Yes, 2 to the power of 4. See, if you take a number as a, if you multiply this a with itself n times, and this we write like a to the power of n. Yes, in this a is called base of a number. So this is a base and this n is called exponent. This n is called exponent. So what does this n indicates? It indicates that how many times a number is multiplied in the product. Okay, and we will discuss some laws of exponents. Okay, here these are the laws of exponents. Okay, see, in the first law is a power 0 is always equal to 1. So a can be any number except 0. So what happens if a is equal to 0? If a is equal to 0, it goes to the form of 0 to the power of 0 is equal to 1. But will it possible to the 0 to the power of 0 is equal to 1? No, right? Because 0 to the power of 0 is an indeterminate form. Means we cannot determine the value of 0 to the power of 0. Then how will it be equal to 1? That is why we are always whenever we consider a to the power of 0 is equal to 1, that time we should write this condition that a should not be equal to 0. Okay, and move to the second law. In this, the a to the power of m, this all to the power of n, then that time these two powers multiplied. Yes, then you can write this as a to the power of mn. Okay, and in the third one, in the third law, see, a to the power of m into a to the power of n. Here the bases are same. A to the power of m, a is the base. A to the power of n, a is the base. So here bases are same. That is why we have to add the exponent. Yes, we can write it as a to the power of m plus n. Okay. And similarly, when you move to the fourth law, a to the power of m divided by a to the power of n. See, here also the bases are same and the powers are different. That time what we have to do when we divided, when we get a divided symbol in between these two, so a to the power of m minus n means we have to subtract two exponents m minus n. Yes, and if a be power of m, this can also be written as a to the power of m into b to the power of n. Means the product value of the product doesn't change if you write this one like this. Yes, because see, if you take 2 into 3 all to the power of 5. Yes, 2 into 3 all to the power of 5. What happens? See, 2 into 3 whole to the power of 5. Now, what is the value of this? 6 to the power of 5. Isn't it? See, even if you write in this format, means 2 to the power of 5 into 3 to the power of 5. So, the value of this doesn't change, and this 6 to the power of 5 value is always equal to 2 to the power of 5 into 3 to the power of 5. That is why we can write this product in this way. Okay. Also write a by b whole power of m, like, which is equal to a to the power of m divided by b to the power of m. See, whole to the power of m means it is a power of both numerator and denominator. That is why we can write in the separate also, means we are writing power to the numerator as well as power to the denominator. So, right, that is why we can write like this. And when you see the seventh one, a to the power of n can also be written as 1 by a to the power of minus n. So, according to this property, a to the power of m by a to the power of n, what can we write? A to the power of m minus n, right? So, this I am writing, see, 0, 1 can be written as a power 0, isn't it? And here denominator is a power minus n. See, here bases are same. What we have to do? We have to subtract the exponents, isn't it? So, a to the power of 0, subtract 0 minus of, here in the power itself we have minus n. So, write minus n. So, what happens? Minus into minus plus a to the power of n, isn't it? So, this is how we can write a power n can be written as 1 by a to the power of minus n. Okay. And see the next law. In this, a by b whole power of n can be written as b by a whole power of minus n. See, this a by b whole power of minus n. This you can write b power minus n by a power minus n, isn't it? Now what I am doing? I am taking this b power minus n can be written as, see, if from this a power minus n can be written as, if you take this a power n to here, this side, 1 by a power n, isn't it? So similarly you can write b power minus n like 1 by b power n by, and here also 1 by a power n, isn't it? So, fraction by fraction, so it goes to numerator a power n by b power n, isn't it? And this can also be written as a by b whole power n, isn't it? So, this is how we can write a by b whole power n, which is always equal to b by a whole power minus n. Okay. And when you see the ninth law, a power m, which is equal to a power n, then this m must be equal to n, but the conditions are applied. This a value should not be equal to either 0 or 1 or minus 1. So what happens if you take 0? See, 0 to the power of 4 is equal to 0 to the power of 5. But will 4 equal to 5? It is not possible. That is why a should not be equal to 0. See, that is same case applicable when a is equal to 1 also. See, if you take a is equal to 1, 1 to the power of 3 is equal to 1 to the power of 4, isn't it? So, 1 to the power of 3 value is also equal to 1, 1 to the power of 4 value is also equal to 1. They are equal, but 3 is not equal to 4, isn't it? That is why we should not take the value of a is equal to 1. So, if you take minus also, what happens? Minus 1 whole to the power of 3, which is equal to minus 1, and minus 1 whole to the power of 5. Yes, odd powers. So, minus 1 to the power of odd power is always equal to minus 1 itself. So, minus 1 equal to minus 1, but 3 is not equal to 5, isn't it? So, that is why when you want to apply this law in the problems, you must check the value of a should not be equal to either 0 or 1 or minus 1. Okay. And move to the next law. 10th law. Here a power of m is equal to b power m. See, in the previous law, bases are equal, powers are different. But when you see this, bases are different, powers are same. And see, if a power m is equal to b power m, then a should be equal to b. But if a not equal to b, then m must be 0. See, 2 to the power of 3 is equal to 3 to the power of 3. Okay. But 2 is not equal to 3, right? 2 is not equal to 3. In order to follow this equation, so the power must be equal to 0. Means this m is, if m is equal to 0, what happens? 2 to the power of 0 is equal to 3 to the power of 0. Now 1 is equal to 1. It applicable. So that is why if not equal to b, if a is not equal to b, then m value should be equal to 0. Okay. Is a standard form of a number. So a standard form of a number can be defined as, it can be expressed as a product of a decimal and a largest exponent of 10. Suppose if x is a number, this we are writing as a product of y, and this is a decimal. This is a decimal between 1 and 10. 1 and 10. It should not be equal to 10, but it is less than 10. Yes. And this y into 10 to the power of z. Yes. This must be largest as possible as largest. Okay. So if write a number in this format, then we can say that the number is in the standard form. You see, if I am writing 50,000, this number in the standard form. Now how can we write? We should write this in this format, and this y value must be between 1 and 10. See, here we have 5. Yes, if we take 5 into 10 power here 4. If you write like this, what happens? This is the value of y. Yes, it is between 1 and 10. Yes, it is between 1 and 10, and this is the largest exponent of 10, isn't it? See, if you increase 4 to 5, what happens? Automatically this will be 0.5. But he mentioned that this y value must be between 1 and 10. Means it must be greater than 1 and less than 10. Yes, isn't it? Yes, that is why we should not write like this. It should be the value between 1 and 10, and this 10 to the power of z value must be as largest as possible. Okay. See, if you take one more example, 348. How can you write this number in the standard form? See, as we have to write in the form of 10 power to the number, what I am doing is I am multiplying and divide by 10. What happens? So if you cancel these two, I am keeping a decimal point here. Yes, and this I am writing as 3.48 into, this can be written as 10 square. Yes, yes, this is a standard form. This is in standard form. How can we say this is in standard form? This is a decimal point he mentioned. So decimal means decimal that must be greater than 1 and less than 10. Yes, it is between 1 and 10. 3.48. Yes, it is between 1 and 10. And 10 to the power of the largest exponent. Yes, 2 is the largest exponent that is possible in this number. Yes. So this we call it as the standard form of a number. If we have in the place of y, if we get a 10 into 10 power 5, is this in the standard form? No, because this value should not be equal to 10. This must be between a decimal number between 1 to 10, means it must be less than 10. You can have 9.5, 9.3 depending upon the number, but it should not be equal to 10. Yes, now you understand? Thank you.